Dr. Siti Rahman had been monitoring Indonesia's seismic network for 18 years. She had seen thousands of earthquakes, dozens of eruptions, but she had never seen them synchronized. On March the 25th at 8:47 in the morning, her screens lit up with a magnitude 8.1 rupture beneath the Flores Sea. Standard protocol, issue warnings, track aftershocks. Then at 10:17 in the morning, her system flagged something impossible. Mount Lewotobi Laki-Laki, a volcano 40 kilometers from the epicenter, was erupting. Not from weeks of magma buildup, but instantly, like someone had reached underground and pulled a trigger. When her team analysed the seismic data, they found the smoking gun. The earthquake had generated what they are now calling a compression wave, a pulse of pressure that travelled through solid rock, hit Lewotobi's magma chamber, and squeezed it until it ruptured. They had predicted this mechanism in computer models, but no one had ever captured it in the wild. And that discovery has unleashed a terrifying calculation. Indonesia has 127 active volcanoes. Most sit within 50 kilometers of major fault lines. If one magnitude 8.1 earthquake can detonate one mountain, what happens when a magnitude 9 strikes and dozens of volcanoes sit in range? Do they go off like fireworks, and would we even see it coming? For nearly a decade, Mount Lewotobi Laki-Laki had been silent. Standing at 1,584 meters tall on the island of Flores, its last significant eruption in 2015 was a distant memory for local residents. Seismometers recorded only background noise, gas emissions were stable, and satellite radar showed no ground deformation. Every scientific indicator pointed to a volcano in a deep sleep, but Lewotobi was about to shatter that illusion. On the morning of March the 25th, without any of the typical warning signs, the volcano roared to life. There were no swarms of small earthquakes that usually precede eruptions, no uptick in sulfur dioxide emissions, and no harmonic tremor signalling magma rising through the conduits. In an astonishing span of just 90 minutes, Lewotobi went from dormant to a full-scale eruption. The only anomaly was a magnitude 8.1 earthquake that struck 40 kilometers away, less than 2 hours earlier. Dr. Agung Harjoko, a volcanologist at Gadjah Mada University who has studied Lewotobi for decades, was stunned by the speed of the awakening. He said, "In all my years monitoring this and other volcanoes, I have never seen an eruption unfold this quickly." He shook his head and added, "We had absolutely zero warning signs. It was as if someone flipped a switch and Lewotobi just turned on." So what exactly happened beneath the surface to spur such a rapid eruption? The answer lies in understanding the different types of seismic waves generated by earthquakes. P waves are compression waves. They are the fastest seismic waves, travelling at speeds between 6 and 8 kilometers per second through the Earth's crust. When the magnitude 8.1 earthquake struck that fateful morning, it sent those high-speed compression waves radiating outward in all directions, and they passed under Lewotobi in a matter of seconds. But these were no ordinary vibrations. Dr. Michael Manga, a geophysicist at the University of California, Berkeley, who specializes in volcanic systems, explains the violent interaction. The P waves from the earthquake essentially squeezed Lewotobi's magma chamber like a tube of toothpaste. That sudden spike in pressure forced dissolved gases in the magma to come out of solution and expand rapidly, fracturing the rock around the chamber. It is the same process that makes a shaken soda can explode when you pull the tab. From there, events unfolded at a blistering pace. The expanding gas propelled magma upwards through the volcano's conduits at speeds of 30 to 40 meters per second, covering the 4 to 6 kilometers to the surface in less than 3 minutes. At 10:17 in the morning, Lewotobi erupted in spectacular fashion, launching an ash column 9 kilometers into the tropical sky. As the eruption gathered strength, its impacts quickly cascaded across the region. The towering column of ash and volcanic gas was rapidly blown east by high-altitude winds, spreading a veil of debris across 40 kilometers of airspace. Flight control radars lit up with the expanding cloud, forcing a rash of diversions and cancellations. Over the following 72 hours, 312 flights ferrying over 85,000 passengers were disrupted, a transportation crisis that cost airlines an estimated $2.3 million per hour in lost revenue and additional fuel costs. But the true devastation was unfolding on the ground below. On Lewotobi's flanks, searing avalanches of superheated ash, gas and rock fragments called pyroclastic flows raced down slope at speeds over 100 kilometers per hour, incinerating everything in their path. While these flows stopped short of populated areas, the rain of ash that followed blanketed communities in a choking grey shroud. In the village of Riangbaring, just 6 kilometers from the erupting crater, the ashfall was relentless. Roofs groaned and buckled under the accumulating weight until some gave way entirely, collapsing into homes and burying possessions under a smothering layer of tephra. Across the region, crops withered and died as their leaves were smothered, unable to photosynthesize. Rivers and streams ran thick with suspended ash, clogging irrigation channels and contaminating water supplies. For the vibrant tropical ecosystems around the volcano, the eruption was nothing short of catastrophic. Birds dropped from the sky, suffocated by the fine particles clogging their lungs. The critically endangered Flores crow, found nowhere else on Earth, was spotted in disoriented flocks, unable to navigate or forage in the ash-choked landscape. In just the first 48 hours, an estimated thousands of birds, small mammals and reptiles perished in the eruption zone, their bodies buried under centimeters of ash. Dr. Putu Santika, an environmental scientist at the Indonesian Institute of Sciences, who has long studied Lewotobi's ecosystems, lamented that the speed of this eruption left the area's unique wildlife little chance to escape. One moment they were in a thriving jungle habitat. The next they were engulfed in a literal storm of ash and rock. It is a grim reminder of the outsized influence volcanoes can have on the natural world. As the eruption gradually waned, and scientists worldwide began scrutinizing the wealth of data from the event, a disturbing larger picture started to take shape. Lewotobi's eruption was no isolated oddity. It had exposed an underappreciated and deeply consequential threat lurking beneath Indonesia's volcanoes. Through advanced seismic imaging techniques that essentially create a CT scan of the Earth's subsurface, researchers at the Indonesian Center for Volcanology and Geological Hazard Mitigation made a startling discovery. Many of the archipelago's volcanic systems sit atop seismic superhighways, narrow corridors of rock that act as highly efficient conduits for seismic waves emanating from distant earthquake faults. These subterranean pressure tubes work like a pneumatic tube system in a drive-through bank, allowing seismic energy from an earthquake to be transmitted to a volcano's magma chamber with minimal dissipation. A careful review of past eruptions in Indonesia revealed that Lewotobi's behaviour, while extreme, may not be unique. Researchers identified at least 6 other instances in the last half-century where a sizable earthquake was followed suspiciously quickly by a volcanic eruption, a temporal link that had previously been dismissed as coincidence or anecdote. With the mechanism of the pressure wave trigger now laid bare, those past events took on a more ominous hue. For Indonesia, a nation that hosts 127 active volcanoes, this realization has grave implications. Dr. G.M. Wei, a geophysicist at Nanyang Technological University in Singapore who collaborated on the research, warned that our analysis suggests that a significant number of these volcanoes may be primed for this type of rapid pressure triggered eruption. We can no longer assume that a quiet volcano is a safe one. Any suitably large earthquake in the vicinity could provide the nudge that awakens a sleeping giant. But it is not just individual volcanoes that have scientists deeply concerned. The most unsettling scenario is one where a truly massive earthquake, like a magnitude 9+ event on the Sunda megathrust offshore of Sumatra, sends seismic waves rippling through the crust to multiple volcanoes simultaneously. Dr. Wei explained that our models show such an event could potentially trigger several volcanic systems hundreds of kilometers apart, a cascading catastrophe that we have not seen in recorded history, but one we may unfortunately witness in our lifetimes. In the months since Lewotobi's stunning awakening, the volcano has settled into a more typical eruption pattern. But the questions raised by those first shocking hours continue to reverberate through the halls of volcanology. How many other volcanoes in Indonesia and around the world are poised for similar pressure-induced blasts? What is the minimum earthquake size needed to trigger one? Could an even larger quake set off a simultaneous eruption at multiple volcanoes in a nightmare synchronization? And if that day arrives, will we have any warning signs at all? For Dr. Rahman, the scientist who first spotted the seismic signature of the pressure wave in Lewotobi's data, the implications are chilling. She reflected solemnly that the event has shaken many of our fundamental assumptions about how volcanoes behave. The idea that we could go from seeing no precursors to a full-scale eruption in under 2 hours is deeply unsettling. It means our warning systems may have vulnerabilities we never anticipated. As Indonesia's tectonic plates continue their slow, inexorable dance, the magma chambers beneath the archipelago's volcanoes are steadily rebuilding their pressures. Silently and unseen, they are loading the subterranean dice for the next big earthquake to cast across the landscape. The haunting question is not if, but when the next volcano will awaken with sudden explosive fury, and will we be any more prepared when it does? This has been an Earth Attack special report uncovering the hidden forces that shape our dynamic and sometimes terrifying planet. Subscribe to our channel to join us as we continue to explore the Earth's most dramatic upheavals and unpack the science behind the natural mega disasters that humble us with their raw, unbridled power. Until next time, keep a watchful eye on the rumblings beneath your feet. You never know when they might signal something much greater stirring below.